page 11 of lines. Finally, we're going to start the Voronoi diagrams. In these questions, unless told to calculate the equations of the perpendicular bisectors, you can construct the lines with a pair of compasses by eye or by using software. Okay. Basically, drawing, right? By finding the perpendicular bisectors between each pair of points, use the incremental algorithm to complete the Voronoi diagrams for the given sites. Okay, so first of all, I'm going to do the first 3 points here. I'm going to do them in red, blue, and green. So the red point is 1, 1. The blue point is 3, 1. And the green point is 2, 3. 2, 3. And these, you can imagine, are all offices or Domino's pizzas, and they are going to cover a certain amount of area of the map. First thing we're going to do is we are going to use a black pen, and I'm going to draw perpendicular bisector between red and blue. So that would be like that, right? Pretty easy, right? Because it's they're lined up with each other horizontally, so we know that the slope of the perpendicular bisector is vertical here. Now it's said that we can draw these eyeballing them, so we don't have to be really exact. If I wanted to draw a perpendicular bisector between blue and green, it would go through the midpoint, which would be right there, right? And it would have a slope which was approximately perpendicular to what's given, so it would be kind of like that, right? And then for red and green, the perpendicular, or the midpoint of red and green would be right there, and so, and the slope of the perpendicular bisector would be kind of like that. Okay? And so that's how you would do a Voronoi diagram, by eyeballing it. If we wanted to find the exact equation of a line, or if we wanted to put on Desmos or something, we would take this midpoint here and then draw a line through that midpoint, which has a slope which is exactly -1 over this slope here of the line which connects the two, right? Just like we did in the investigation. All right, let's go to the next one. So the next one has 1, 1, 3, 1, which are the same as the previous one. And then the third point is 3, 5 instead. So let's see what's different about that. So 1, 1, 3, 1, and 3, 5. Okay, and so if we drew a perpendicular bisector between red and blue, it would go through this point, which is the midpoint, and it would be vertical, because the line connecting red and blue would be horizontal. It needs to be perpendicular. If we wanted to draw a perpendicular bisector between the line segment connecting green and blue, we would go through this midpoint here, and it would obviously be horizontal because red, green, and blue, the line connecting them would be vertical. So, and then finally, if we wanted to do a border between red and green, it would go through this midpoint, and it would be perpendicular to the line connecting green and red. And this is the line connecting green and red, right? So the line perpendicular to that would be kind of like that. Okay? So that would be the Voronoi diagram for this scenario. Let's go to the next one. A neighborhood has 3 bookstores located at 1, 1, at 5, 1, and at 5, 5. Construct the Voronoi diagram for the 3 bookstores ABC by either hand or using a software package. Determine the closest bookstore to Carl, whose house is located at 1, 4. Okay, so let's see. So 1, 1, 5, 1, and 5, 5. Oops, I wanted to do that in green. Hey, come on, green. 5, 5. Okay, then we're going to draw the borders in between red and blue. Red and blue are connected by this line segment. The perpendicular bisector of that line segment would be like that. Green and blue, the midpoint is here, and the line connecting that would be like that. The perpendicular bisector would be like that. And red and green, the midpoint is here, and the line connecting them would be like that. The perpendicular bisector would be like that. Okay? So that's my Voronoi diagram for the bookstores. It says, determine the closest bookstore to Carl, whose house is located at 1, 4. 1, 4 is here. So we can tell that Carl is in the region of the red bookstore, right? So he would be using the bookstore at 1, 1, which is the red one. A fourth bookstore was built recently at D, 3, 5, which would be right there. Okay? Construct the Voronoi diagram for the 4 bookstores A, B, C, D. Determine whether there is another bookstore that is now closest to Carl's house. If so, determine which one. So now what I'm going to do is I'm going to redraw the first 3 bookstores, and then I'm going to do the 4th bookstore. 5, 1, 5, 5, and the new bookstore is at 3, 5. And remember, Carl is at 1, 4, so I'm just going to put Carl there, K. And now I'm going to draw the borders between red and blue. The perpendicular bisector of that line would be this line. Between blue and green, the perpendicular bisector of, the perpendicular bisector of that line would be this line, right? Between green and black, the perpendicular bisector of that line would be this line. Oh, that's not nice. And the perpendicular bisector between, let's see, black and red the perpendicular bisector of the line segment between black and red would be like that, right? Okay. So you can see that Carl is now just over the line in the new bookstores region, right? And let's see, if I do black and blue, which we've done black and green, we've done black and red, we didn't do black and blue yet. The perpendicular bisector to the line segment between black and blue would look kind of like this, right? And that would affect this corner here, wouldn't it? So I'm going to get rid of that. It would look like that now. Okay? All right. Let me redraw that. Okay, like that. So Carl is now in the region of the new bookstore. All right? And I needed to make an adjustment. Did you see how the corner of this part here got cut off because of the new border between black and blue? Whenever you put in a new bookstore or Domino's Pizza, what you need to do is you need to check the border between itself and all the other existing close by Domino's to see if any of the borders are going to change. Okay? Now, this one was kind of hard to do visually because you can see that like the slope is like not trivial to draw. If you want to see how to draw this slope without generating the equation of the line, you can see that the line segment I do between black and red is run 1, rise 2, right? So that means that the perpendicular is going to have run 2, rise -1, right? That's why it ends up being that direction. And on the next page, we're going to do some where we actually generate the equations of the line, and then I don't know if that'll make it even more difficult or it might clear it up for some people, but let's try that.